So let's go ahead and draw out some storage here. Although I'm drawing out a attached storage device, we'll draw that out just because it's a storage device that I have an animation for. But essentially, the storage environment by which data analytics runs now has changed a little bit. So for a while now, we've been at least a decade, if not more, we've really been focused on block and file storage, and we've really been focused on network attached and storage area networks that attach into a server. Years ago, we used to be direct attached storage, which is similar to what we're talking about here, although it was local. And we always had challenges managing it, RAID, allocations, things of that nature. So we would over provision a box, but we wouldn't have much to use. Now storage, so then we went to storage area networks and network attached storage, and that worked out great, except now with data analytics, the key to a performance-oriented analytical environment is to have the storage as close to the compute as humanly possible. So that basically means that we want servers again with storage on them. And so we see a big shift in the industry doing that. And so we want to have this storage on the servers. Now, this is not to say that storage area networks and network attached storage is dead, not by a long shot. We still have the need to store data for long term. We're going to be going from probably block and file into object-based storage, but we're still going to need array heads and power and be able to search information and do all kinds of stuff with block traditional storage. But for data analytics, we want it on the same box. Now I've read several studies that indicate that a SAS 10 or 15K drive, for example, does not perform much better than a 7.2K drive. So, but there is a cost savings for the slower drive. So it's suggested that you just get a slower drive to put on these machines and build them out. And then, of course, remember that we need to have multiple drives within the environment so that we can do what they call a map reduce to disk mapping, because we gain some great performance by having map reduce tasks specifically assign themselves to disk themselves within the architecture.